Hello students, welcome to video lecturing class on control engineering. So in the last class, we started with the mathematical modeling of the physical systems. We have seen the definitions, basic definitions, and what are the elements of the mechanical system, and how to consider their force terms, that is for the mass, spring, and a damper. We have solved 2-3 simple problems. So we'll continue with the problems. So here, this is the given problem. So you need to find out the transfer function of the given system. Okay, so whenever he asks you to write the transfer function, or whenever he asks you to write the differential equation, the very first step is you need to draw the free body diagram as well as equivalent mechanical system. Whether he has asked or not, you have to do these two steps. That is, first one is free body diagram, and then second one is equivalent mechanical system. So here in the given problem, there are two masses M1 and M2. M1 is attached to K1. In turn, this K1 is attached to this fixed length. And between M1 and M2, we are having the C, that is the damper. And here it is K2. And on M2, F of T is applied. Here, he asked us to consider the frictional coefficient. Okay, that is B1 for this one and B2 for this one. So that is the friction between the surface and these rolling wheels. Okay, so first and he asked us to take this x2 as the output. So basically, whenever if he has not mentioned which one is the output, so that time directly would have taken this x1 as the output, because output will be always the thing which is happening at the last. As you can see here, this f of t is acting on M2. First, the initial displacement will be on M2. Because of displacement of this M2, the displacement takes place in C and K. Because of these displacements, the displacement of M1 will occur. That means the output will be the displacement of this M1. But here he asked us to take this x2 as the output. Okay. So the value of this x2 is greater than x1. So I will tell you what is the difference. Okay. Now, to draw the free body diagram, draw two masses M1 and M2. So start from a mass on which the input is acting. Either it may be force or displacement. So here on M2, the f of t is acting. So f of t is in this direction. So when this M2 is trying to move in this direction, this C and K2 will try to resist that motion. So direction you have to go in opposite way. So once you show the intermediate directions on this surface of M2, so on M1 will be in the opposite direction. Okay. Then when this M1 is trying to move in this direction, this K will try to resist. And frictional force always it will be act in opposite to the direction of the motion, that is direction of the displacement. So here B1 into x1 dot, B2 into x2 dot. So this is the free body diagram. Then you need to draw equivalent mechanical system. For that, the very first step is you need to identify the number of displacements. So since there are two masses having two displacements, so mark those two displacements by nodes. Here this is the x1 and this is the x2. For that you need to identify the elements which are associated with individual displacements. Okay, so here the x2 is happening on M2. Only this term is connected to x2, but this C and K2 are between x1 and x2, and this M1 is connected to K1. Okay, so first on x1, so which are the elements are having only x1, those elements you need to identify. Okay, so M1 is having only x1 and K1 is having only x1. Along with that, this force due to this friction, that is B1, is also having x1 only. So attach these three elements to x1 node here, M1, B1 and K1. This C and K2 are between x1 and x2. So show those two elements between x1 and x2. Now for this k2, sorry, x2, m2 is there, b2 is there. Okay, so m2 and b2. On this end, I have to show the input, that is f of t. So this is the equivalent mechanical system. For this, you need to write the differential equation. So to write the governing differential equation, you can use Newton's second law of motion. That is, acceleration force should be equal to 0, or the algebraic sum of the forces which are acting on the body must be equal to 0. So now, the first equation, always try to write the first equation for a mass on which the input is acting. Okay. So in this case, on M2 here, your input is there, f of t. So first we'll try to write the differential equation for this M2. Okay. That is M2 into x2 double dot, that is going to be the acceleration force, is equal to, so here your x2 is in this direction, so your acceleration force will be in the same direction, that is will be in the direction of the applied force. Okay, so take the forces which are acting in this direction as positive, the opposite direction as negative. So m2 into x2 double dot equal to f of t, because it is acting in the same direction, minus b2 into x2 dot, because this b2 into x2 dot is acting in opposite, and these two forces are also acting in opposite direction, plus c into x1 minus x1 dot minus x2 dot, plus k2 into x1 minus x2. So here, even though these two forces are acting in opposite direction, but we have taken this sign as positive, because here we have written it as x1 minus x2. Okay, so he asked us to take that x2 as the output and x1 as f of t as the input. But when you take x2 as the output, that time its value will be greater than x1. So put together, the next displacement will be negative. So otherwise, you can write it as x2 minus x1. If you are going to take negative sign, that time you have to write it as x2 minus x1. So here, that is the reason why, to avoid that one, we have taken it as x1 dot minus x2 dot, plus k2 into x1 minus x2. Similarly, for the second mass, m1 into x1 double dot equal to minus c into x1 minus x2 dot, minus k2 into x1 minus x2, minus k1 into x1, minus b1 into x1 dot. So here also, even though these two forces are acting in the same direction of the displacement, we have taken a negative sign only because in this problem he asked us to take this x2 as output, but the value of this x2 is greater than this x1. So if you write it as x1 minus x2, so that time obviously we will get it as negative, so no need to worry about the sign. Or we can simplify this equation as 2 into x2 double dot minus c into x1. So bring all the terms towards one side, only f of t towards right side, and here simplify the second equation to get this equation, then take the Laplace transform of both the equations. So here this equation will be m2 into s square into x2 of s, because it is x2 double dot, minus c into x1 dot minus x2 dot is there, so it will be s into x1 of s minus s into x2 of s, plus b into x2 dot is there, so plus b2 into s into x2 of s, minus k2 into x1 minus x2 is there, minus k2 into x1 of s minus x2 of s equal to f of t will become f of s. Similarly, the second equation will be m1 square into x1 of s plus c into s x1 of s minus s into x2 of s, plus k2 into x1 of s minus x2 of s, plus k1 into x1 of s, plus b1 into s into x1 of s is equal to 0. Now, from these equations, we can rewrite these equations by taking the x2 terms towards one side and x1 terms towards another side. That is, yes. I have taken x2 of s as common. So m2s square plus cs plus b2s plus k2 minus cs plus k2 into x1 of s equal to f of s. This is from this equation. Now from second equation, I will take x2 of s as common. So I left with minus cs minus k2 into x2 of s plus m1s square plus mcs plus k1 plus k2 plus b1s into x1 of s equal to 0. So this is name this equation as 3 and 4. Now by using these two equations, need to find out the transfer function. So here transfer function means it is output by input. So here output is x2 of s, input is f of s. So to get this ratio, we will try to use the determinant method. That is, so here we want the ratio of x2 of s by f of s. So we will write the determinant equation for x2 of s. So x2 of s equal to, in this numerator, in the first column, by using determinant method, so if you write the equation for x2 of s, you will get this determinant. So after solving this determinant, you will get x2 of s is equal to f of s into m1s square plus cs plus b1s plus k1 plus k2 divided by this term. The transfer function will be x2 of s divided by f of s equal to 1s square plus cs plus b1s plus k1 plus k2 divided by this denominator. Okay. So the next one is determine the transfer function for the given system. So here f of t is applied on m2. So first and m1 is there, d2 is between m1 and m2, and this k and d1 are attached to x end. So first we will try to draw a free body diagram, m2 and m1. So f of t is acting in this direction, so displacement is acting downward. So this d2 and d1, we will try to pull it up. So on this surface, you have to show it as upward direction. This same force is acting on m1 on this surface in the opposite direction, that is towards the downside you have to show. So here while showing, these direction should be opposite always for the intermediate elements. And m1, when this mass m1 is having downward direction, so that time this spring k will try to pull it up, that is k into x1 will act in the upward direction. So we need to draw the equivalent mechanical system for this. So first you need to identify the displacements. So there are two displacements, x1 and x2. So I'll name this node as x2 and this one as x1. And x2 is associated with only m2 and d1 because this d2 is between x1 and x2. So first you attach this m2 and d1 to x2 node, and this d2 is between x1 and x2. So do that element between x1 and x2. And for this x1, m1 and k are attached. So this is m1 and here it is k. So this is the equivalent mechanical system. So after that, need to write the differential equation by applying the Newton's law. So acceleration force, for as I said, always your first equation should be for a mass on which the input is given. So here the input is given to this m2. First, for this mass, we will write the differential equation. So m2 into x2 double dot is acting towards the downside because the displacement of the body is towards downside. So therefore, m2 into x2 double dot equal to the forces which are acting towards the downside, we have to take it as positive, and upside we have to take it as negative. So f of t is acting downward and remaining these two forces are acting upward. So f of t minus d1 into x2 minus d2 into x2 dot minus x1 dot. Similarly for m1, again m1 is having x1 as the displacement towards the downside. So m1 into x1 double dot will act towards downside, which should be equal to, so here downward forces positive, upward forces negative. It depends upon the direction of the force or the direction of the displacement. So d2 into x2 dot minus x1 dot, because this force is acting downward on this surface of this mass m1. The same force on m2 it is upward, but on m1 it is downward. So we are taken as positive, minus k into x1 because it is acting upward direction. So by taking the Laplace transform of these two equations, and write it as m2 into s square to x2 of s equal to f of s minus d1 into s into x2 of s minus d2 into s into x2 of s minus s into x1 of s. Similarly for the second equation. So now we will try to simplify these two equations. So bring the displacement terms towards one side. So here the first equation will be m2 into s square into x2 of s, and this side it will be f of s. Similarly, bring all the terms from the second equation towards one side, get this equation. So now from these two equations, try to take the common terms outside. So here from these three terms I will take x2 of s as common. I are left with m2s square plus d1s plus d2s into x2 of s minus d2s into x1 of s equal to f of s. Similarly, from this equation I will take x1 of s as common. So first I will write minus d2 into s into x2 of s plus m1s square plus d2s plus k1 into bracket x1 of s equal to 0. Now to get the transfer function, we will write the determinant equation. So while writing the determinant equation, first you should know which one is the output and which one is the input. So here input is f of s and output is x1 of s. So we will try to get the ratio of x1 of s by f of s. So we will write the determinant equation for x1 of s. So in the numerator, in the first column, write the coefficient of x2 of s from these two equations. You are writing x1 of s, equation for the x1 of s. So write the coefficient of the other displacement. So here the other displacement is x2. So from the first equation, the coefficient of x2 is m2s square plus d1s plus d2s. Right. In the second row, again the coefficient of x2 is minus d2 into s here. In the second column, you have to write the terms which are on the right hand side. So here in the first equation it is f of s, and in second equation it is 0. For example, if there is one more variable, say x3, so that time that x3 coefficient should come here. In the denominator, repeat the first column as in the numerator. In the second column, you have to write the coefficient of the same displacement, that is coefficient of the x1. Okay. So from the first equation, the coefficient of x1 is minus d2 into s. From the second equation, coefficient of x1 is d1 m1s square plus d2s plus k1. Okay. So in the numerator, in the first column, coefficient of other displacement, because you are writing the equation for x1, write the coefficient of x2. And in the second column, terms which are on the right hand side. In the denominator, first column repeat as it is from the numerator. In the second column, you have to write the coefficient of the x1. Now solve this equation to get the ratio of x1 of s divided by f of s. So we will get, and here while cross multiplying this term into this term, it will be 0 minus this into this. So already it is with minus sign, so minus d2s into f of s. It will become minus into minus, it will become plus. So this is the final transfer function. Similarly, the next one. So obtain the transfer function for the given system. So here f of t is acting on m1, and he asked us to consider the frictional force, and this damper is attached between these two masses. Here it is k and here it is 2k. So first we'll try to draw the free body diagram. m1 and m2 first draw. Show the forces. It is input, f of t is acting in this direction. When this m1 tries to move in this direction, this spring will try to resist that motion. So the direction of this k into x1 will be negative x axis. Similarly, when this m1 tries to move in this direction, this damper will try to resist that motion on this surface. So on this surface it will be in opposite direction. The same force is acting on M2 in positive x direction like this. Then if M2 is having positive x direction, that time this spring will try to resist that motion, so direction will be opposite. And always these frictional forces will act in the direction opposite to that of displacement. So Fx1 dot, Fx2 dot will be in opposite direction. Then you need to draw the equivalent mechanical system. For that, you already identified the displacements, that is x1 and x2. Now you need to identify the elements which are associated with individual displacements. So from the figure you can see here, from the free body diagram itself, check the terms which are having only x1. So k is having x1, f is having x1, and this m is having x1. So attach these three elements to x1. Similarly, x2 with f, 2k is with x2, and this m2 is with x2. So attach those elements to x2. Now try to find out the intermediate elements. So this 2f is a combination of x1 and x2. So show that element between x1 and x2. And here let us give the input as f of p. Now from the free body diagram, we need to write the governing differential equation. Acceleration force should be equal to restoring force. For the mass m1, the displacement is in positive x direction, the acceleration force will be in the same direction, and this f of t is also in the same direction. But this swing force and damper are in opposite direction, and this force due to friction is also in opposite direction. To take those terms as negative. So here m1 x1 double dot is equal to f of t minus 2f into x1 dot minus x2 dot, because we are in opposite direction, minus f into x1 dot minus k into x1. Similarly, for the second mass, in second mass is also having x2 in the same direction, that is positive x, but this 2k spring will try to resist that motion. So 2k into x2 will be in opposite direction, frictional force in opposite direction, but this force due to damper will be in the same direction as that of displacement. So that will be with positive sign here. M2 into x2 double dot equal to 2f into x1 dot minus x2 dot minus f into x2 dot minus 2k into x2. So apply the Laplace to these two equations as was already gone through the previous problem. So that time if it is double dot s square into x, if it is x dot s into x, if it is x, only x of s we need to write. So apply those techniques to get the Laplace equations. We will get these two equations. So now we try to simplify it in such a way that bring all the displacement terms towards one side and forces towards one side. So in only one equation we are having force term, that term should be towards right side. Okay. So now from these two equations, take the common term. That is, from the first equation I will take from these three terms, that is this 1, 2, 3, 4. From these four terms I will take x1 of s as common. So we are left with m1 square plus 2fs plus fs plus k to x1 of s minus 2fs into x2 of s equal to f of s. Similarly, from the second equation, if you take common as x1 of s, it is associated with only one term, that is 2f of s into x1 of s plus, but x2 of s is associated with four terms, m2s square plus 2fs plus fs plus 2k equal to 0. Or you can simplify to get this equation, x1 of s multiplied by this term, x2 of s with this, x1 of s is with this, and x2 of s is with this. That is just you need to add here, because both the letters are same. For example, instead of giving you f and f, it has given f1 and f2. So that time you cannot add the things. Okay. Now using the determinant method. So here the input is f of s and output is x2 of s. So we'll write the equation for x2 of s. So while writing the equation for x2 of s, in the numerator, in the first column, you have to write the coefficient of other displacement. Other means coefficient of x1. So from the first equation, the coefficient is m1 square plus 3fs plus k. Write that term. In the second row, coefficient of other term from the second equation. So x1 of s coefficient is minus 2fs, that term here. And in the second column, you have to write the terms which are on the right hand side. That is f of s from the first, 0 from the second. Divided by, in the denominator, you have to repeat the first column as it is from the numerator. In the second column, you have to write the coefficient of x2 of s itself. Okay. So in the first equation, the coefficient of x2 of s is minus 2fs. From the second equation, the coefficient of x2 of s is m2 into s square plus 3fs plus 2k. So take the determinant, try to simplify this term into this term, it will be 0, minus this into this will be minus 2fs into f of s. So here output is x2 of s, input is f of s. So try to get that ratio, you will get the transfer function as 2fs divided by m1 s square plus 3fs plus k into m2 s square plus 3fs plus 2k minus 2fs whole square is the transfer function. Okay, so here while solving the problem, the very first step is we should be able to draw the free body diagram. While drawing the free body diagram, the direction of forces are very important. So always start from the mass on which the force is acting or on which the input is given, so that it will be easy for you to show the direction of the forces. Okay, after that you have to draw the equivalent mechanical system. Then you have to write the governing differential equation. So while for writing the governing differential equation, your free body diagram should be correct. Once you write the governing differential equation, after that you need to apply the Laplace transformation. Once you arrive at the Laplace equations, try to simplify those equations by taking the displacement terms as common like this. Then by using that determinant method, you can easily get the transfer function of the given system. Okay. So in the next class, we'll start with the electrical systems, that is how to draw the electrical circuits for the given mechanical system. So electrical analogy will study in the next class. So here, once you go through this video, you take the problem statement and a diagram, then try to solve by yourself so that you will understand where you can stuck or where you can face the difficulties. Okay, don't simply copy or don't simply go through the video, and if you are just copying from the notes, you will not understand what are the difficulties to solve the problem. Okay, thank you. If you are having any doubt, you can comment in the comment box.